Hey 8th grade, this is Ms. Harkness, and this video is for Eureka Module 5, where we're looking at volume, specifically for Lesson 12, where we looked at the volume of a sphere, and then we also looked at composite volume as well. So you may remember that composite volume is a combination of volume. So it means that the three-dimensional shape is made up of more than one shape. So in this video, I'm going to show you how to calculate a combined volume. Well, in order to solve for volume, we need the formulas. So for a cylinder, it is pi radius squared height. For the cone, it's 1/3 times pi times the radius squared times height. And for the sphere, it's 4/3 pi r cubed. So I'm going to use these formulas within these questions. So here we have this question, and it says calculate the composite volume of the ice cream cone. Anytime we're solving for volume, we want to ask ourselves 3 questions. The first one is what shape? We need to know what shape we're working with. The second one is dimensions. We need to know the radius and the height if we're dealing with a cone or a cylinder, and then we need the radius if we're dealing with a sphere. Then the third question we want to ask ourselves, what is the formula that we are going to use? So for the answer for the first question, we're actually working with 2 shapes here. The first shape we have is a sphere. You can see that in the ice cream cone. That should be a no-brainer that the ice cream itself is the shape of a sphere. And then the other shape here that we're working with is a cone. Again, that should be easy to recognize. The cone is a cone shape. So we're actually going to need a couple different dimensions. For the sphere, we just need the radius, which is given to us. It's 3. And then for the cone, we need the radius, which is also given. It's 3. And then the height, which is 6. Now, I'm going to use my calculator as a support, but for the sphere, you may recall it's 4/3 times pi, so 3.14, times the radius cubed. So 3 times 3 is 9, times 3 is 27. So I'm going to multiply those together. And that equals 113.04 centimeters cubed. Now I'm going to find the volume of the cone, which is 1/3 times pi, so 3.14, times the radius squared, so 3 times 3 is 9, times the height of 6. Again, I'm using my calculator as support. And when I compute that, I get 56.52 centimeters cubed. Now remember, I'm working with these 2 shapes, so I need the combined volume of those 2. So I'm going to add together the 113.04 and the 56.52, and my grand total, the composite volume, is 169.56 centimeters cubed. So as you can see in this lesson, we're just combining all of the volume formulas. I only use the cone and the sphere, but something with a cylindrical shape would work the same way. You find the volume of the cylinder, then the volume of the sphere. Or if it's something like a silo, they're shaped like this. You might have seen them at a farm before, right? You've got that cylinder on the bottom, but then you actually have a sphere on top that is half of the sphere. So you would find that sphere's total volume first, then you would divide in half before adding to the cylinder. Again, this is for Module 5, Lesson 12.